So in step 14, you'll notice one change is it added a list of colors. So what's that going to look like? Oh, cool. So now it's not just black tiles for every single number. Now we have, depending on the number, it gets a different color. So the way I did that was kind of tricky. It used some funky math. I'll show you down below. First I started out just creating a list of all the colors that I wanted to use. So we've got orange for the number 2. If I move this around a little bit, you'll see now I've got red for number 4. I've got pink for number 8, or magenta actually. Let's see if we can get the next one. Yeah, we've got green. We've got blue. So it goes through for each number changing to a different color. All right, and how did I do that? Well, right when it creates each tile, which is actually inside of the draw grid model, now before it decides what color to make it, right here, of course, it's just checking if it's blank. If it's blank, we still want it to just be that gray color, E. But if it's not, now I have a while loop that checks how many times I can divide the number by 2 before it ends up at the number 1. So I'm just creating a variable starting out at 1 called the number of divisions that have happened so far, getting it down to the number. Because if you start with a number like 32, divide that by 2, you get 16. That's 1 division. Divide that by 2, you get 8. That's another division. Divide that by 2 again, you get 4. That's a third division. Divide that by 2, you get 2. That's 4 divisions. So that number increases depending on how many times it takes you to divide the number to get it down to the number 2. And I'm just using that number of divisions, subtract the number 2. I'm not sure why I had to subtract the number 2, but that works perfectly. So I'm using that as the index for which color to use from that list. See right here I'm saying background color is going to equal whatever I get from that list when I look in the spot using the index of the number of divisions it took to get the number down to 2. All right, and then the last step, I believe that's everything that was added here. Yep. So the last step is we wanted to make it so that when I run out of space, because if you notice while I'm still here on step 14, when I run out of space here, as soon as I've pressed enough buttons, eventually there shouldn't be any space for me to move. So it should be game over. For some reason it's still okay, there we go. So I'm not able to move anywhere now, and it should tell me that the game is over. But we don't have anything checking to see if the game should be over. So each time I move or collapse something, I want it to check whether it's actually able to add a new tile. So in step 15, all we had to do to add that, we just said, we created a function called check game over that looks like this, and it's just going over each row and each column, so each spot, it's saying, hey, if you're empty or if you're able to collapse with your neighbor, then we're going to say the game's not over yet, so return the value false. But if it gets through the whole grid and it can't find an empty one or one that can be collapsed, then it will say game over and it returns the value true, so the game is over. And this function check game over gets called each time you try to add a new tile. So it adds a new tile and it checks, is there now anywhere where the person's able to move? Can it collapse anything? And oh, by the way, that function we just created too. What that looks like is we said, given a row and a column, so some spot on the grid, let's check if there's something to the left of it or to the right of it or above it or below it that can be collapsed. So if it has a neighbor that's the exact same as it, then obviously something can still be collapsed. So that will return true. Otherwise, if none of those cases result in true, then it returns a false at the very end there. All right, so let's test that. I believe that's everything that we added for that function. Yep, I think that's it. Let's test that out. Now if I just go ballistic here, moving the arrows up, down, left, right, eventually I'll run out of spots for me to move. It's still collapsing some things. That's why it's taking so long, because there's a lot of 2s and a lot of 4s initially, but eventually things get bigger and so there's nothing to collapse. And as you can see here, it said game over because there's nothing for me to do at this point. So if I tried to move up, down, left, or right, can't. All right, so that is 2048, the 15 steps it took me to program it.